support and confidence, and we took a small example for that. Okay, so I will just show you the formula for that and how it is going to be, then what is its impact and what for we need to do this. So these things I will just briefly introduce, and then we will go ahead with the next steps of this. Okay. One more thing I would like to announce you. On 19th, Saturday, we will have an extra class in the afternoon, because I think your schedule is over by 19th, right? So for that sake, I am just proposing this, okay? Because I have to be very quick in covering the syllabus also at the same time. Whatever it is. Because this is the scenario related to all the university colleges. So and it's my responsibility to cover the stuff to the possible extent. Actually, I thought of having it coming Saturday, but second Saturday is holiday for most of the colleges, hence I don't want to inconvenience people. And in between, if any other vacant slot is there, maybe I'll try to take on some working day, because even my remaining schedules are also very uncertain as I was involved in other activities. Okay. So here, now first of all, why do you need association rule, and then what is the prominence of support and all? I just told you last time introduced. It seems people are vague about the concept, I felt, right? Are you clear with the concepts? Support and confidence? How confident you are? You can raise your hands. Yes, good. You three people. What about the remaining? Then I'll just very briefly introduce about this as a recap of what has been done and go ahead. See, the very purpose for finding out this kind of support and confidence, these things are the market basket analysis is to find out which items were sold very frequently in a specific stores and which items go together, move together, so that the strategy of making some offers can be logical, because we see somewhere buy one get one free, or buy two get one free, buy three get one free, or buy one get the second one for half price. Like different deals are there. So now how do they decide these deals? Why not for everything buy one get one free? No. For an Apple computer or for an Apple iPhone, you need not give buy one get one free offer, right? Even if you say that 10% discount on Apple iPhone, people will have a very big queue, right? So based on the moment, based on the profit it is making, based on the rotation, based on the brand value, all these aspects will decide the real economics of the how it works out like for the product. So based on that economics, people will decide how to handle this like. Okay, so based on that, why they give a kind of offer is, right now I am getting this much profit. Suppose if I give my offer and reduce the price by so much, the volume of business increases this much. So by rotation, I can get much more profit. By selling something for 10 rupees, if 100 people buy, selling it for 7 rupees, if 500 people buy, reduce your profit margin, sell it for 7 rupees, whereas 500 people, you have an increase in the rotation, then your net is very high. And it's not only net apparent thing, your brand value also increases. If 500 people buy, the brand value increases and the additional benefits you get are much more. So people look for that kind of rotation. Hence people give a kind of discount for any of the items in the sales and everything. So that's what happens basically. So for this, to give that kind of offer and all, before that we are having two measures. If you look at what is the input again, the point of sale transaction, that is the input for your analysis, right? So in the point of sale transaction, when you are giving the input for your analysis, okay, among these point of sale transactions, you will find out in these transactions which items are going frequently together. So that is to be obtained, right? So in this context, we have defined two measures. One is called support count and another is called the confidence. Okay, that means for anything I make a statement like milk and diaper are purchased, means B is also purchased, that's the meaning of it. Or if you have X arrow Y, that implies if X is procured, Y also will be procured. That is the meaning, that is the statement. So at any point of time, if you could give concretely that kind of statement to the business organizers, you have the advantage that yes, somebody who is going to buy bread is buying milk also. Bread and milk are going together in my shop. Then it helps him to take some decision making and this. Okay, then he will see what is the rotation of bread, what is the rotation of milk. So how much I can reduce to increase the rotation, how much decrease in the price will cause how much increase in the rotation. All those things he will assess further based on the remaining statistical data. But for that he should know basically that yes, here if milk is being procured, bread also is being purchased. That's the thing. So in this case, the support, what is meant by the support? So here the statement made is X implies Y. That is a meaning. So here that means if you say that X is purchased, that implies Y also will be purchased. That's a meaning. So for this, in order to make the statement, we say that we need some kind of support for this. What is meant by the support? How do you go about the support? It is sigma of X union Y over N, where N is the number of transactions you have in the entire database. So you are given a set of transactions. From this you are supposed to find out which are the frequent items and which are infrequent items. Okay. So the support count is N is total number of transactions. What is X union Y? Yes, exactly. The number of transactions that contain both X and Y. So you are making some statement that if somebody buys X, he will buy Y also. That is the meaning of it. So with reference to how many transactions you get this, that is one important criteria. Suppose you have 10,000, I say that a person buys bread also buys milk. Suppose I made a statement. There are 1,000 transactions in the database, but out of which there are only 2 transactions which contain both milk and bread. So out of 1,000 transactions, if only 2 transactions happen on bread and milk, can you say that it is a general thing? Do you believe in that? They could be very casual transactions. So you should have sufficient background to substantiate your stand. Okay. This is what I told you. In third year class, the students are very good, I made a statement. Then immediately principal will ask me, how many students you observed? If you say that only two people are good, suppose you have considered two cases in the class and those two are good, doesn't mean the entire class is good. How many students you have examined? Then by and large, if more than 50% or 60% students are good, then we say that that is a good class. If more than 50% of the students bunk the class, then we say that they are irregular. Okay? So, to make that statement, there should be sufficient support for that. So, this support count is that aspect. So, that means here the number of transactions that contain both and X and Y constitute how much percentage of your total database size. So, if it is some 20% or 25% something, then you can say yes, these observations are sufficient to make a statement. Again, that support count or threshold will be decided by the business people. For certain things you may require less support. For certain things to make a statement you require bigger support. It is a business functional aspect which you have to consider. Do you agree with me? So that is the reason why support is one measure based on which, suppose you are making a statement, means yes, how many of these transactions are there in the total database that consists of both X and Y. Based on that support only, you can make some statement, right? Now the second issue is your confidence. What is meant by confidence of X? It is sigma of X union Y by sigma X. That means the number of transactions that contain both X and Y over only the transactions that consist of X. That means you are making a statement that if X goes or if X is procured, Y also will be procured, like you are making a statement. Do you agree? So, now how much confidence you have for that statement? That means among the transactions that contain X, how much percentage of transactions are there having both X and Y? Suppose there are transactions with X, 10 transactions are there with X. Okay? And then the confidence is how many transactions you have both X and Y. So among the 10 transactions that contain X, 7 transactions contain both X and Y. Then you say that the confidence is 70%, because you are saying whosoever procures X will procure Y also. So that means you should have, first of all the transactions that procure X. Okay? Should have all the transactions that procure X. And then you should augment. Then you should count how many have both X and Y. That means, okay, if 10 transactions are there with S, there are at least 7 transactions that contain Y also. So, yeah. Suppose I say some 2 students, we say that they always move together. Suppose I make a statement. These 2 people are good friends and they always move together. I make a statement. Then, what is the confidence to say this? If you will observe, okay, are they going to the class together? Are they going to the mess together? Are they going to the movie together? Are they going to bunk the classes together? Okay? All these things we will see. Okay, they are bunking classes together, they are going for movie together, means yes. Yes, you can confidently say they two move together, right? Do you agree? So, that means you will observe total events. Out of the total events, if for the major events these 2 are moving together, then you say that yes, these 2 people move together. Okay? Maybe when he is going to his house, he may not go to the house because his native place might be Vijayawada and other native place might be Visakhapatnam. So for going to the hometown, it might be different. But whereas bunking the classes, going for the movies is common. So that's why the majority of the transactions, you say that they move together. So that is the confidence. So here, for making any statement, you should have the measures support as well as confidence. Both the measures need to be essentially considered. Okay? Even if I say, that means, I tell you again, once again, if, let us say, I'll tell you this way also, if support is there and confidence is not there, what is going to happen? If confidence is there and support is not there, what is going to happen? Suppose I say support is there. There are 50% transactions that contain X and Y. So if I make any statement on X and Y, yes, it is a very valid point. Okay? It is a very valid point. Suppose I say X is rice and Y is wheat, let us suppose. Or X is rice and along with rice, we say dal, let us suppose. Okay? X and Y. X is rice and Y is dal, let us suppose. And if you consider majority of the transactions in the star, there are 1,000 transactions. At least there are 400 to 500 transactions that contain rice and dal or something. Okay? Then what you can say, so if you make any statement on rice and dal, that's a valid statement, right? Because you have sufficient support. Then I say rice and dal go together, let us suppose I make this statement. Then you might be having 50% of the transactions, that is 500 transactions consisting of rice and dal, but amongst them the transactions with dal are very less. Okay. Then what happens to you? The statements you make will not have sufficient support. Confidence will not be there. Okay. Confidence will not be there. So here that will be the problem, because they may not go together sometimes. Then if confidence is there, if I say yes, if some egg is purchased, bread is also purchased to have bread omelette, let us suppose, but there are only 5 transactions supporting that, then how confidently you can say? You can't generalize every time that bread and omelette they go together, right? So both are essential measures for having the things. Okay. Now you can go to the, I think yesterday PPT I have shown you the confidence level, same confidence, but support is different. Last class it is over. Okay. You can go to the next page here. Show here. Next page. Right. Okay. Next page. Yes, you can stop here. Picture ఒకటి మీరు elaborate చేయండి. ఇంకా maximum you can. Because I'm not concerned with the content there, but I'm concerned with the picture there. Okay. See here, is it visible to you people? Hello, affiliate callers, is it visible to you? You can respond me one. Is it visible? Picture, is it visible? So now we got the idea of the support and confidence, why you should measure them, and what is going to be the impact of finding out the frequent items. Now our problem here is to find out the frequent item sets. That is one aspect. We want to find out the frequent item sets. How many items are going together? That is the frequent item set aspect. Okay. Then when can you say that some item set is frequent? Yes, exactly. When there should be a good support count for the items to go together. That means, in order to say that which are frequent item sets, let us suppose there are k items in your shop. So transactions, how they can be? There can be single item transaction. You can go and just buy 100 kgs of rice and come out. Or you may buy rice and wheat. Okay. Or you may buy rice, sugar and wheat. Or you may buy rice, sugar, bread, milk and wheat. Right? That is how you can buy any number of items. So here, if you look at the number of items in one transaction, how many it could be? What could be the range for number of items in a transaction? 1 to k. That means because how many maximum items he can buy? The maximum number of items that are available in the store is the maximum number of items they can buy. Do you agree? So beyond that can't buy anyhow. So that is the thing. That's a cap on that. What is the minimum number of items they can buy? It's one only. No buy means no transaction at all. So the number of items in a transaction can vary from 1 to k, the maximum number of items that are available in the stores. So now what we do here is, because what is our aim? To find out which are all the frequent items that go. Okay. So the frequent items that go means they could be 1 item transactions, there could be 2 item transactions, there could be 3 item transactions, 4 item transactions, like up to k item transactions. Do you agree with me here? So the transaction width is from 1 to k. Okay? Is it fine? Now the thing here is, so here we are considering there are only 5 items in the stores. So here, because we don't know anything about what I say, your FP tree or about your a priori algorithm, we don't know anything. When we do not know anything, what is the very first level or primitive level algorithm to find out? It will be a brute force method only, right? It's a brute force method only. So what is that you have to do? So if you look at, first of all you have to see what are all possible permutations and combinations of these items. You have to see. So he is just building a lattice here. Here in this shop, we imagine that there are a maximum of 5 items sold in this. Then with these 5 items, what are all the possible combinations that exist? So null of course is always there, and from the null, of course you will not have null transaction, so that we will avoid, but the lattice we are showing. So it originates from null. So the 1 item sets are A, B, C, D and E, right? Then what are all the 2 item sets? They are AB, AC, AD, AE. Then BC, BD, BE, AD, CE, DE. These are all possible transactions with 2 item set. Okay, that is the point. AB, AC, AD, these are all possible 2 item sets. Okay. Then after that, what are all the possible 3 item sets? With AB, what are all the other possibilities? ABC, ABD, ABE, right? There are three possibilities there. Fine. Then with the AC, what are all the possible things? Because AC D and AC E. Because AC B is nothing but ABC is already there. So only with higher things you will go. So with AD it is ACD and ACE. With AE, ACE. Okay, these are all possible combinations. See, with AB, ABC, ABD, ABE. With the AC you have ACD and ACE. With the AD you have only AD. Right? These are the possible things. Now with the AB is over, with the AE it is over. Now with the BC. With the BC you have BCD only. Because BCA is over already. Okay. So BCD. And with the BD you have BD. Sorry, with the BC, BCD, BCE. And with the BD, BDE only. Okay. With the BE, BDE only. And with CD, only CDE. With the CE, CDE. And with the DE, CDE. Okay. These are only possible combinations for this. Okay. Sorry, I'm sorry, for CE you have already ACE already there. CE, BCE is already there. So additional thing is CDE only. Okay. So that is how the combinations are possible. Now using these things, ABC again, ABCD is possible, ABCE is possible, two combinations. With ABD, ABCD and ABDE, these are all 4-level combinations that are possible with these things, and ABCDE is the final apex transaction. There could be only one possibility for 5, right? ABCD. So the lattice C starts from 5, then went up to 4, 5, 6, 7, 8, 9, 10, and 10, then 5 and 1. So here, how many number of combinations are possible? 2 power k minus 1, because you remove the null section. Because all possible combinations with null are 2 power k. That minus 1 combinations are possible for any size k. Okay. So if you look at it, will be 31 combinations, or with this it is 32. This 6, 26 plus 6 is 32. Right? Those many combinations are there. Now if you use the brute force method, what is that you are supposed to do? You have to take A and you have to search the entire database, because you have to check every transaction. First transaction, A is there or not? Yes, it is there. Then initially say that support count is 0. A is there in the first transaction, then count is 1. Transaction 2. Is there any transaction with A? No. So count is 1 only. Transaction 3. Yes, A is there. Make it 3. Then again another transaction. A is there. Wherever it is immaterial. If A is there, tick it. Like this, you will count all the transaction in the database. So your capital T is nothing but the transaction database. Capital T is the transaction database. So you have to scan the entire database to find out the frequency count of A. Is it clear to you? You have the transactions with, suppose I will show you the transactions here. ఇది అవుతుందండి, అయితే మామూలుగా అట్లా చూపించాను పేపర్. Suppose the transaction 1 has got Kanincha. Huh? Transaction 1 I am saying. The items are A, C. Transaction 2 is B. Transaction 3 is A. Transaction 4 is only A. Transaction 5 is C. Transaction 6 is G. Transaction 7 is B. Okay, these are the transactions. Let us suppose you have 7 transactions like this. Now how you will count is A is here 1, 2, 3. So the support count for A is 3. Sorry, 1, 2, 3, 5. 1, 2, 3. Where is A? Only at 3 places is there. No, it is CB, it's not A. 7th one is BE. I have. How it is shown as A? I have written E here. Sorry, it is not A, it is E. But the thing is, it is, see, it is very much shown in a distorted way. The 6th transaction is EC, I have written. And the other one is BE, I have written, not A. See, what I have written here is not reflected with the same proportion there. I am wondering now for that. So I can just show you, see how E I have written and how it is reflected. Totally distorted. There is a problem with this. See, I have written BE with so much of clarity. Huh? Hand should be. Okay, hand, that is different, but the picture is not exactly repeated like. Okay, no issue, but I'll write down here. Okay, B, E. Okay. I see. I should base here. Okay. But how come it is? But we have seen the letter, right? It is giving a different image. I'm wondering. Oh, you have to keep the hand away from them. Okay. See, so E is 3. So similarly, if I say find out the support count for CE. CE is there in the first transaction. CE is EC or CE is one and the same. 2 combinations only. So the support count for CE is 2. That is how you will. What is the support count for ACE, if you consider? It is 1 only. There is only 1 transaction. What is the support count for ADE? It is 0 because no transaction with ADE, right? So that is causing the problem there. Okay. So how you will count the thing you have understood. So that means to find out any support count, what is that you are supposed to do? For each and every item that is generated there. So that means you, in the brute force method, you will generate first of all the candidates, all the possible candidates for k items, right? All the possible items for k candidates, and then you will search them one by one in each and every transaction. If that pattern is there, you will increment its count by 1. And by the time you finish one transaction over the entire database, if you traverse through all the transaction of the database once, frequency count for one specific pattern will be known. So in our case, this is of course with 7 things, leave it. In our case, wherein I have 5 items, so the K is 5, so the number of candidates generated is 31, right? So among the 31, so that means the transaction database has got 7 values, right? So that means for every item, for A, you have to search the entire database. So searching the database means you have to access the database, and that is the one that is going to consume the maximum number of time, because the processing is nothing. Because I have been reiterating very frequently to you that transforming one block instruction processing time takes nanoseconds. So if at all any query is to be answered, the time that is considered is only the number of block transfers. Compared to the number of block transfers, the processing cost is just merely negligible. You can just ignore the processing cost. It's only the cost of transferring from secondary. That's the only cost we really incur in answering any of the queries. So here, if you want to find out now these support counts, because what is that you will do? For each and every item candidate that is being generated, because in this database you don't know how many candidates are there. There are 2 item transactions, 3 item transactions. Like this you don't have any 4 item, 5 item transaction at all. Maybe you can have AB, another transaction is ABCD, another is EFGH, EF only, or F is not there, BCE. Like you can have some transactions, right? So you will, for every possible combination, you have to count there. Okay? So that means 31 times you have to search the database. And please remember here, for our example, for sake of example, I have shown you 7. Of Walmart in a day, it's 2 petabytes, right? Okay. And today even the Hadoop platform with 910 clusters size is taking 206 seconds to transfer 1 terabyte of data. So peta means it is 1000 terabytes, right? So that means it will be 1000 into 206 seconds. So that itself will cost days, a lot of hours. Okay. Still you have to increase the size and all if you want to really deal with petabytes. That is the thing. So that is the real-time scenario. So in such case, one transaction itself for the database, suppose the database consists of some 10 million transactions or 100 million transactions. Let's suppose. Even once traversing the database itself is a pretty expensive task. So just for 5 item set you have to have 31 times. If it is a 10 item set, you have to have 1023 times, 1024 minus 2 power 10 is 1024, right? So 2 power k minus 1 transactions. So if you use a brute force method, It's going to be prohibitively expensive. You just cannot imagine running that practically. So now, using the brute force, when this is the problem, how can we go ahead with this? So let us solve, let us find out certain methods to resist the issue. So for this, there is a property called a priori property is being introduced. What is this a priori property basically? The a priori property is, if an item set is frequent, all its subsets are also frequent. Suppose I say ACE is there. ACE has repeated 5 times in this database, let us suppose. And we say that the minimum support count is 5 means it is 5. It's greater than or equal to 5 means that is considered to be frequent. Because we define basically the minimum support count and minimum confidence count. These two things we will have. So now what we say is, yes, the minimum support count for ACE is, we have defined the minimum support count as 3. Suppose there are 4 transactions of ACE. Then we say that, yes, the minimum support count defined is 3 and you have 4 transactions of ACE. You say that. Now once you say that like that, now what happens? We say ACE is a frequent item set. Once I define ACE is a frequent item set, A will be frequent, C will be frequent, B will be frequent, AC will be frequent, CE will be frequent, AE will be frequent. So here, if you say that some set is frequent, obviously all its subsets will be frequent. Do you agree with me for that? No challenge for that word, right? Because there are 3 transactions with ACE means obviously with A you will have more transactions than that. With C also more transactions, with E also more transactions. With CE, with all sub combinations you will have at least that number or beyond that only. Certainly you will not have less than the transaction count. So all subsets of a frequent set are frequent. That is one property. And another property is, suppose if you have one item set as infrequent, all its supersets will be infrequent. Suppose here you consider ACE is there. The transaction count for the ACE is only 1. I have shown you before. So then it is infrequent because I said the minimum support count is 3 for that. Okay. So when it is failing, when ACE is 1, then the supersets of it also will be infrequent, right? If ACE is there, there is only one transaction, then supersets means ACED, or ABCE. These are all supersets, right? Consisting of this. So their frequency count also could be maximum 1 or 0. Or if ACE is 2, there the supersets also can have 2 or less than 2 only. But beyond 2 you will not have any supersets, right? If some set has got 2 occurrences, all its supersets will have 2 or less than 2 occurrences. Beyond 2 will not have. So if I say this pattern is infrequent, all the subsets of it are also infrequent. That's what I can make as a statement. So using these two things, we will prove the candidate transactions can happen, and without brute force, how many things can happen, right? Okay. So here what we will do is, in this kind of a priori methodology, you first generate all the possible candidate list. Then you will find out the one item frequent sets. Infrequent things you eliminate there itself. So if you eliminate one infrequent items from the table, automatically in the next level combination you formulate, you will not be having any things with those infrequent things. So with these possible things only, you formulate possible 2 item sets. And among the 2 item sets, again you eliminate the infrequent ones. Then only frequent 2 item sets only will be considered, and formulate like that. Okay? And when you are considering in these combinations, by any chance, the combinations with eliminated things are there, its supersets can comfortably be eliminated. You need not. So that means you will be avoiding finding out the support count for the remaining infrequent things. So that is how you can reduce there. How we will reduce there and all, we can see. PPT, you just go to the PPT. Basic assessment. So you can go ahead with the slides. So here, item set, support count and everything you have defined. Yes, next slide. So evaluated the matrix, support and confidence for those things. The problem and brute force approach. This is done already. So now another thing is, what is the example for the rules that are being generated? See, the rules also can be generated with permutations and combinations. So suppose if I give some items, you can have rules generated also with permutations and combinations. And not every rule is viable, because if you eliminate through frequent item sets and all, you will have less number of sets that are possible, frequent items. Now with those frequent items, you will generate all possible combinational rules, and then for each and every rule you will find out the confidence. And if the support for that, the confidence for that is there within the confidence threshold, those rules you will keep and rest you will know. That is how you will generate frequent items and these things. This, come on, next. So two-step approach, frequent item generation, then rule generation. Generate all item sets whose support is greater than minimum support. Then generate high confidence rules from each frequent item set, where each rule is a binary partitioning of a frequent item set. Okay. So frequent item set generation is still computationally very expensive, because even if you, through a priori, even if you eliminate, maybe out of 100 you may do 30 transactions, but still 30 times you have to compare the database, which is still very expensive. So your FP tree algorithm is one good solution for that. That uses only 2 scans of your data. It's a very complex thing, you have to understand properly. So that's why I will spend more time on your FP tree, because you have to very carefully follow the transactions, how the sets are being generated, and with utmost clarity it is needed. So next slide please. So next slide. Yes, brute force method. He has shown here some items. There are 5 transactions he has shown here, and with these 5 transactions, video close next low. We have the items like bread and milk. The transactions are bread, diaper, beer and eggs, milk, diaper, beer and coke, beer, milk, diaper and beer, bread, milk, diaper and beer, bread, milk, diaper and coke. These are the transactions we have. And 1, 2, 3, 4, 5, there are 6. How many numbers are there? List of candidates. You have bread, milk, diaper, beer, egg and coke. Right? There are 6 individual items in this transaction. So he has shown there. So here, match each transaction against every candidate. What is the complexity of this? Here, the order of complexity is, you have number of transactions m, n. M is your 2 power d. That means how many frequent items will be, how many items set are possible. There are d items there. Because I said k, but he has taken the connotation d. So it is 2 power d. M is 2 power d. That into W is width of transaction is said. That is d. That is the maximum thing, that W. So it's the order of n into m into W is the complexity for this algorithm. Are you able to follow this? Because how many times you have to check one specific item means the width of a transaction, maximum width is W, that is defined, and what are all the possible combinations? There are 2 power d, that is called as m. Number of transactions is n. Because I just now told you that for every possible candidate you have to search the entire database. So for all possible combinations you have to search the database n into m times. And W is the maximum width I said. So based on the width you have to search for this W. You have to search all the transaction, all the items, those many. So those many items need to be checked. So complexity is that order. Next step please. Next slide please. The total number of items is 2 power d. Total number of possible association rules is 3d minus 2 into d plus 1 plus 1. Yes, he is giving, because we discussed how many frequent items are possible. That is one thing. But with these things, how many possible rules can be generated? They had a formula. Let us not bother about its derivation and go into deep of it. But suppose if you have 6 items, the possible combination of rules has given a formula. R is equal to 1, K is equal to 1 to D minus 1. Dk means it is dck. Okay, into sigma J is equal to 1 D minus K. D minus K Cj. It is dck into D minus K Cj. Those many rules are possible. Because I told you rule generation is different. For rule generation you have different combinations possible, because X determine one item set determining Y. So suppose 6 items are there. Item 1, 2, 3, 4, 5. Those are the rules. Then item 2, because X implies Y is different from Y implies X. So there you have to consider on both these sides. 2 power d is the possible combination. And if it satisfies the threshold confidence level, then you say that yes, this rule is possible. So having filtered this much, I can say yes, third year CSC class is a good class. Okay? If I have sufficient support and confidence. So, this is the scenario. Next slide, please. So, see how expensive it is. Just to 6 items, you have those. So, reduce the number of candidates, reduce the number of transactions, and okay, reduce number of companies. Now, the approval principle which I have already told you, but one mathematical aspect I have to consider. You have some rule called monotone rule. That monotone rule says that for all x and y, if x is a subset of y, implies s of x is greater than or equal to s of y. Oh, you got the anti-monotone. So you have a set x and set y. And we know that x is a subset of y. Okay. Then your sx is greater than or equal to sy or y. That means your support of an item never exceeds the support of it. That implication. Okay. Here, s of x is greater than or equal to s of y. That means support of the subset is always greater than its supersets. That's what I was talking to you. Suppose the impedance of the support of AC is 2. Obviously, supersets could be maximum that or even less than. So this is called anti-monotone property. This anti-monotone property. Next slide. And monotone property is something like this x subset of y and some function of x is less than function of y. That means the rule which I said for everything, if some item set is frequent, all its subsets are frequent. That means if ABC frequency is 3, then the frequency of remaining subsets will be more, right? Or equal to that. But certainly cannot be tested. That is a term. Anti-monotone property is otherwise. Okay? So those two properties we discussed. Now the thing is illustrating approval principle. See how the pruning happens. How the pruning happens. Suppose I said at some point of the observation, AB is found to be infrequent. Then when AB is infrequent, in the lattice, all its supersets can be eliminated. So that means because of your anti-monotone property, what you will do is, because otherwise you have to make 31 searches in the database, right? You have to make 31 searches in the database. Once I say that AB is infrequent, I decide all its supersets I can eliminate from checking all the proved supersets of it. So how many are being checked? 1, 2, 3, 4, plus 4, 8. Out of 31, 8 have gone. So 8 times you need not search your database. That is the traversals of the database are being reduced. Okay. Next slide, please. Is it clear to you? bread has 4, Coke only 2, milk 4, beef 3, diaper 4. So then Coke people are drinking beef now. It's really unfortunate thing I should say. Some 30, 40 years back, somebody is drinking people used to. Now people say somebody is not drinking. Okay. That is the scenario today. The very reason being, yesterday, to really happen to listen to one lady talking, think of she's 60 years plus old. She said, when I was 40 years old, I could very comfortably move in the society in the night without any fear. Now I am 60 plus and I am scared of moving on the road. That is the kind of change with reference to insecurity for the weak. And I tell you, this is all possible because of the consumption. And that changes the attitude of the person. So just for the sake of money, we stopped prohibition. And many people went, and son will follow the father of it. So at some stage it has come such a level that it has become a very common habit. And of course in Western countries where thing is different, their education level is different. Number of persons are different. So they will not have any control. If it goes to the masses, once they are drunk, they will not have any control in things. And at your prime age, if you lose control over you, obviously, you don't know to what kind of state you see. You take the statistics of any of the crimes. Drinking is a major habit. Because of that, a person, man will lose his balance and become mad. That's why the level of violence and crime have increased across countries. Really, I appreciated that. And consumption of liquor is one cause for our environment. Where illiteracy is more, where superstitions are more. I'm saying illiteracy, not the knowledge. For the people who are educated, knowledge. Even the educated people are committing the crime just because of this. You might have seen in Inadu some months back or 3 weeks back. One doctor had a problem. He's a corporate hospital. There was a dispute with shared distribution of the money. He's very well off and the people are well off. So suppose they want to settle down. If they sit in a cool atmosphere, they can settle down. But ultimately what happened, he consumed 2 bottles of liquor fully and just called the other partner for discussion to the farmhouse and not easy. But if you are not losing balance, he is composed, the crime would not have happened. That's it. Because you may say, what is this you are talking suddenly about? Because you being you want to just possible crime. Where the people should control. So you have to take up fight. Still people are going to prohibition. Of course it has become a minor thing and people will not bother about it. But this is the ground reality. If prohibition were continuing long time, today this kind of insecure society will happen. I tell you, after another decade, probably even a gent will be scared of going along the lane. item subsets will have 2 item subsets and 3 item subsets. So how many will be there? 6C1 plus 6C2 plus 6C3. These are all the possible combinations there. So how much is that? That is 41. So you have to have every subset is considered. 41 database comparisons are needed. But here, what is that? Using a priori, minimum support is 3. So you eliminated means Coke and X are being eliminated. Coke and X are being eliminated. So you have 2 things eliminated. Now you have only 4 items there. So 4 items are there, and then with those 4 items you will make the combination of 2 item sets. So now what happened? I have shown you the lattice. If A, B is infrequent, I have shown you certain things. If A itself is infrequent, what happens? Further more things will be eliminated, right? All its combinations you can ignore simply. So more number will be eliminated. Here as 2 items are eliminated, their combinations of Coke and egg, all those combinations will be totally eliminated in the first round itself. So your lattice space drastically reduces. Then you have, now if you consider 2 item set support count, bread and milk is 3, bread and beer is 2, bread and diaper is 3, milk and beer is 2, milk and diaper is 3, beer and diaper is 3. How do you get these counts? You go to the database, you will see bread and milk, how many combinations are there in that. Why I am telling you is because I am going to show you the algorithm after this. So in order to understand the steps of the algorithm, you should have examples. Okay? To be clear here. Huh? Okay, we'll finish now. Huh? So we are just here, if you look at, we are proving bread beer to milk and beer to. These 2 transactions you are again eliminating. So because of that, many combinations will be eliminated. And if you consider with these 2 set rules, only one triplet 3 items combination is there: bread, milk, and diaper. It is just with support 3, and your support based pruning is now 6 plus 6 plus 1, only